been about 70 years since Zeus, the first programmable computer, or one of the first, and we still grapple with this problem of knowing what a machine actually does when a human tells it to do something. We have not yet really kind of dealt with this computational behavior and knowing what a machine does. This is just a very simple simulation of a couple of robots. They have collision detection, and very simplistic rules produce a very complicated machine where this poor little robot gets stuck in the middle. Not intended, but a circumstance of the machine and the simple instructions it was given. There are kind of a couple of approaches we've taken to dealing with this computational behavior and trying to make a machine do what we expect. In computer science, we tend to remove the human and think about theory, and that makes it very easy to write very interesting, complicated proofs, but it doesn't necessarily focus directly on the human-computer interaction side. But kind of engineering, I guess, takes a more kind of disciplined stance on this, with thinking about pair programming and unit testing and integration tests, all these techniques to make sure the machine does what we tell it to do. And what I'm talking about is the idea of the performer, where it's less about building a system, building something, an API, and more about that moment of interaction with a human and a machine. I used to think that these things were very separate, but kind of without computer science, without engineering, performing wouldn't be possible. And I think I would argue that, in fact, performance means engineering and computer science are possible. I really think these are the same things. To give you an example, creating a programming language is involving computer science and engineering, but refining that programming language and using it, performing with it, helps you refine it and understand how people are going to use it. So I would argue that all of you are performers. It may not just be that you have an audience, but you are performing, and this is critical to computer science and engineering and performance. Also, to perform, the stuff I'm going to do in this demo requires understanding of temporal semantics. There's at least a couple of research papers about adjusting for garbage collection and scheduling, understanding OpenGL, understanding synth composition, understanding timing signals, using temporal recursion. There's a ton of stuff. So also, I'm not underplaying performance. Performance is just as technical and as demanding and as respectable as engineering or computer science. Code has kind of moved also past the executional semantics. This is an example that was sold on an Artsy of the Hello World program, written in pen. So the execution doesn't matter. It's almost now become a form of expression, and this has value to people. This is a fantastic poem created, I think it was a Stanford Code Poetry Jam, using CSS. And again, it's using expression. It's taking CSS and someone is expressing themselves. And actually, I think it's kind of a beautiful use of CSS, poetry, and expression. Sorry, that's Zach Kane that did that one. So what I'm going to kind of at least give you a bit of a demo of and talk about is the idea of live coding. So I kind of don't want that many slides. I'm just going to show you some videos of what people are doing and kind of give you a brief overview of what live coding is. One of its core principles is that the code should be seen as well as heard. It's often used in music. And that algorithms are thoughts. When you're watching someone live code, you're watching them express their thought process. So here's a couple of examples of things people are bound to their fingertips using programming. This was from Sheffield, and a lecturer at Leeds University called Alex McLean, that was working on generative poetry and also combining visuals and music with that. So again, kind of exploring not just live coding for music, but live coding as poetry or live coding as writing. This is Katie Sicho. So she's a choreographer, and what she's doing here is she's projecting her code onto a dancer, and the dancer is reading the instructions she's writing and executing her choreography. So she's actually sitting on the side there with a laptop coding the performer. And she's also done pieces where she fits, I guess, sensors across the top of the performer's chest, and they vibrate. And that's also how she programs a dancer live. And the dancer is kind of her screen, so we're seeing what she's composing. It's kind of beautiful, actually. She's doing some very interesting stuff. This is Dave Grissis, a part of the band called Slub, and he's reimagined that maybe the IDs we have aren't great for live coding. So he's created, in his own graphics library, this kind of block semantic language where each color there is actually just a closure. And the flashing light is the signal firing back and forth between the various synths, and he can drag blocks around, manipulate things, exploring that maybe when we think about the liveliness and an audience watching you, maybe that changes the tools that we want to use and the experiences that we have. One of my favorites, can't see him that well, but this is Alex McLean again, and a drummer. This was in Leeds a couple of months ago. And he's live coding using Tidal, a language written in Haskell, and he has a drummer who's playing on a MIDI drum set, and they're playing together, coordinating, which is fantastic, called Canute. They've got a bunch of stuff on SoundCloud and various platforms to listen to. This one's a bit of an oddball, but I wanted to at least mention it, because I think it's an interesting perspective of the actual body of the computer that we don't really think about that much as programmers. So this is John Rufus, known as, I think it's iMac, and he's hacking into an iMac computer, into the circuitry, creating various visuals and music and noise. I think this is interesting because it's actually looking at the machine and not just the code. So he's still live coding, he's just got it working at a different level that most of us don't function at. And that's interesting that the machine and the body affects the way he performs. Also, live coding has really kicked off with a lot of remote programming. This is the Cybernetic Orchestra based in Montreal. There's about 20 of them, and they are all live coding using Tidal again and a web browser. And they're executing little patterns. Each of them has a speaker next to them, and then they tend to do like a ring of music where each person jams with the previous person, or a composed piece. We did this a couple of weeks ago with, I think it was 40 people, all live coding and doing graphics and music together. One of my favorite examples, and I guess something that shows you how far live coding has come, this is Sam Aaron, formerly of MetaX, live coding in Emacs in a nightclub, and people are dancing. Now, this is amazing in itself, but it's also fascinating that Emacs was not designed to code music. And this laptop really wasn't designed for someone to go into a club and code in Emacs. But people are not just doing what they're expected to do with the technology, but breaking it apart and trying to decide for themselves how they express themselves. So we've come a long way. A lot of the early work in computing was looking at like algorithmic music, about music generation. It's just that we're reaching points where we have the power and we have the portability to go to these venues and actually perform to an audience. So I think live coding is a thing, the performance coder, especially, it was a good example of the Minecraft programmer. He was streaming, I think, via Twitch, his coding sessions. And I had a friend whose daughter was watching it absolutely glued for like 2 hours just watching him code. So performance programming is definitely a thing. It's becoming more popular, but my worry is I don't want this just to be a thing that exists in universities. I don't want this to be like a niche. Code is a means of expressing yourself. And I consider that being able to read code and being able to write code gives you a way to express yourself in the same way that writing or reading enables you to express yourself. So I want people to understand code. And that comes about through injecting programming into kids' brains. Building audiences. This is my daughter, Alice. And we do this through a tool called Sonic Pi. Sonic Pi is a C++ app, but it runs Ruby server, so it's a Ruby language. It's being used in schools to live code music, to teach music, and to teach programming. And it's also translated into German as well, and I think there's an attempt to translate it into Japanese as well. So this is a fantastic tool to teach children programming and build computer literacy through a creative and fun way of programming. But I don't want to leave you with the impression that this is a kind of a kid's toy. Sonic Pi is an instrument. Code is an instrument. And while we are very young in our development and understanding of how people use this instrument, we have had people across the world playing in nightclubs using Sonic Pi. It runs on Mac and Windows, but also runs on the little Raspberry Pi, which is why it's so great for teaching in schools, because it's so cheap to buy these little things. And people are taking them to nightclubs actually using them. So those are the words. Now I kind of want to give you a little bit of Sonic Pi, and then a little bit of closure and overtone, just to kind of show you where we're at with Sonic Pi, and maybe show you how it works, and also show you a performance of where I'm most, I guess, literate. Okay, so let's exit the slides. I am doing so many things you're not supposed to do in a presentation, like running Xcode and running hacked code, and so many things could go wrong, but that's kind of the point. That's what makes it fun. Okay, so I'm just launching a shader. Let's make that a bit bigger. Let's just go F10. Let's get the log back. Just go here. So this is Sonic Pi. I'll just show you the log. A very simple setup. It's a little gray because I'm actually using a hacked version of my own in order to be able to show you a little bit of some of the graphic stuff that I've been working on. Cool. It's a little dark. How is that? That's not too bad. Okay, so to show you a brief overview of Sonic Pi, the first thing you do, the simplest possible path to making noise. Right? A simple play. You're playing a note, and numbers go up and down, so it's a very simple way to... But there it didn't just play 60 and play 50. Those are MIDI notes. It actually played them simultaneously. So immediately, as kids and as musicians, we're thinking about performing in parallel. These two things happened at once. But then with a little sleep command, we can just tell it to wait. Sleep represents actually a beat. So let's just play 0.5 and play another note. Not very interesting, but with two functions, we can pretty much play all of Western music. So that's pretty cool, right? And that also means 10-year-old kids can do this. And that's a big requirement of Sonic Pi. Kids should be able to do it, musicians should be able to do it, connecting the two. But again, like, music is a cool thing to teach kids because, okay, that was crap. But if you sit down with a child and say, like, let's make a computer game, they're like, okay then, so I want a dragon and a fortress and like fire and like you run in on a horse, and you're kind of like, yeah, I've drawn you a circle and it moves a bit. So it's hard, but music is actually not too crazy to get started. So I'm just gonna kick something off here. Okay. So of course samples are where we come in for some magic here. So beat. Use sample BPM of D. We just stop. We get lots of nice errors because we didn't tell it to sleep. You can't do infinite loops. That would just be crazy. So we're going to play the sample that I just assigned to a variable. This is all just Ruby. And let's sleep for sample duration. Right? Play the sample, sleep. And with very little code, I mean, there's some stuff up the top here, but that's just to make me faster. With this little function here, we have something that's starting to sound a bit more like music. And this is kind of where it starts to grow and you start to play of like, well, okay, we can add another sample and we can say, well, maybe, yeah, go for it. Well, I can do that myself, actually. Code. And D1. So again, I can make patterns, which are great ways of expressing music, samples. So I just created 4 of this sample, 4 of that sample, and it's going to loop through them. And concurrency is something that you don't necessarily need to understand, music naturally is concurrent. We have a drum loop, but that's not enough, right? We don't say, well, what about putting a nice kick drum in there? So immediately, as programmers and as kids, we need to understand the concept of concurrency, and not just concurrency, but synchronization. So I can tell this to actually sync on the previous live loop, which is just called drums, so it's just matching up the names, and let's put a, oops, double sample, let's put a kick drum, and I'm just looking through samples here. A random end. Let's make them. All right. So we have another kick drum. We can then pick patterns. This is all just Ruby. We can start to mess around with shuffling things, randomly choose one. We start to mess around with effects. We say, let's do a quick synth as well. Also, you'll notice there's that little dot moving in the background. Specifically, why I wanted to show that is because this is something I've been working on for Sonic Pi, and it's the first time it's actually ever been used. I'm quite happy it didn't crash. We can start to control graphics as well, which is fantastic for music and for programmers, for kids. So I'm just gonna, let's uniform. This is an OpenGL shader running in the background, and I am going to try and add some randomness. Let's see if that actually works. So we can start to make pretty graphics. We can start to not just think about composing scores, but I was thinking about algorithmic complexity, having unpredictability. So we could say scale, pick a scale, let's choose S2, and let's do something nice and simple, major tectonic, shuffle, choose, choose a note, release, 1.0, and again, these things just kind of grow and grow and grow, and you can have a lot of fun. I spent most of the day just messing around with this stuff. We can start to bring synths in. We can start to change the synths. So we can, let's say with diesel. So again, lots of autocomplete. A bit sharp. Let's have a cutoff, that's why. Very simple, but a really nice way to create music, to express yourself creatively, which is fantastic for kids, it's fantastic for adults. Again, I can just execute arbitrary code, make things go faster, and grow the code. So there's a brief demo of Sonic Pi. Now actually I want to show you, I'm still getting to grips with this and having to build a lot of the graphic engines, so I'm not yet at a point where I'm ready to fully go with Sonic Pi. I'm still working on it. As I said, I have no music background, so most of it is removing all ego. Most of this is me learning like how to do chords, how to do samples, how to do all very basic stuff that I have no experience of whatsoever. So this, let's just kill everything. So performance is good. This is now I'm going to slip into overtone. Pretty much everything I do here you could do in Sonic Pi, but this is where I started live coding, and I kind of want to show you the best that I can do with Closure. It's using the same sound engine super collider that Sonic Pi is. So everything I'm doing here, you can just go away and do better in Sonic Pi. So I recommend you give that a shot. So now I'm going to try and do a performance, and let's hope everything works. Let's just make sure we have transparency. Cool. Okay. So the title of this was like end of buffer, but I was really inspired by one of the previous talks about removing ego. So this is Joe learns chords. This is the real, like, first time I ever actually tried to do chords properly. So, ooh, there we go, that's better.
You need Emacs for making music like you need it for having sex. And for the uber geeks in the audience, just to be specific, that is not at all.